Hi, Abdulaziz. I'm just going to quickly rush through the slides for you so you can go through it many times and good luck in the presentation tomorrow. Um, the project is design, simulation, and harmonic analysis of AC voltage regulator using PSpice. PSpice is an electronic simulation software that we use to design power electronics, and we show by simulation our results, the result of our design. Now, what is AC voltage regulator? AC voltage regulator is, as the name goes, is an AC voltage controller. It helps to regulate AC voltage. For example, there are some loads that require regulated AC voltage, AC power, and AC current. You want to control AC voltage, you want to control AC power, you will need an AC voltage regulator. So, what is the aim? The aim of this project is to investigate AC voltage regulation, design an AC voltage regulator, and perform harmonic analysis of the AC voltage regulator using PSpice. So from the word regulator, regulator means to control, to regulate basically. So I'm going to show a schematic of an AC voltage regulator here. This is an AC voltage regulator. This VS is the AC voltage source, and then we have two thyristors that are arranged in an anti-parallel form. What it means is that they are facing opposite directions. All right, and then we have the load. This is a resistive load. Now, the output voltage here is not a constant voltage. It's going to be changing. It's going to be controlled by these thyristors here. So that is what we mean by AC voltage regulation. So we have AC input, constant AC input, but the output is a variable output. That means the output is changing. The output is controlled. The output is regulated. This is the meaning of AC voltage regulation. And what does the regulation? These thyristors T1 and T2. Actually, they are silicon controlled rectifiers, SCR. They are used to provide the switching action for the load, and they control the voltage, the power, and the current from the AC source. So we want to control the voltage on this load, the power, and the current. What we do, we take the AC input and pass it through this combination of thyristors, and we are able to regulate the output voltage. Now, one thing that's very important is what is called the firing angle. The firing angle of the thyristor. The firing angle will determine the output voltage, how the output voltage will be. So I'm going to show you some mathematical equations now for the. This is the equation for the output voltage. The equation for the output voltage is given by Vm over pi bracket 1 plus cos alpha. Vm is the amplitude of the input voltage. That means this input was the amplitude. I mean, it's an AC voltage, so it has an amplitude value. Maybe let's say its amplitude is 50 volts. So this is going to be 50 volts divided by pi bracket 1 plus cos alpha. Alpha is what is called the firing angle. So you see now the output voltage depends on the firing angle. And then this is the root mean square voltage, which is also dependent on the firing angle and the amplitude, the maximum of the input voltage. All right. So basically, what we have said is that we have an AC voltage regulator that takes an AC input and gives you an output that is regulated. So these are some of the key formulas: the output voltage formula, the RMS voltage formula, and the alpha is the firing angle. We don't need to go into deep mathematical details now. All this will be in the report. So I will just show you the simulation, PSpice simulation of this circuit, of this AC voltage regulator. Some results. Some results are this. This is the AC input voltage. This is normal input voltage. Now, if we set the firing angle to 0, so there is no firing angle, all right. That means the firing angle is is 0. All right. We have so we have with a 0 firing angle, right? That means this basically becomes a kind of a scaling up of the output voltage, and then we have the output looking like the input as well, just that with higher amplitude. So by the time we start to change the firing angle, we'll begin to see that the output voltage is now being regulated. Look at this particular waveform. The triggering angle, the firing angle, what is called, or what I call triggering angle. This is firing angle. Firing angle is 30 degrees. So you see that the voltage is no longer like the original input. It's changing. So the voltage is regulated. Now by the time we increase the firing angle to 90 degrees, we'll see that in the waveform, in the positive half of the waveform, positive side, we only have about a quarter of the voltage in the positive side, about a quarter in the negative side, like that. So you see that the wave is now being controlled. This is the voltage that will be available to the load. It's now being regulated. It's no longer like the input voltage, which is this. So you see that the output voltage is not constant again. It's being regulated. This is what we mean by AC voltage regulation. And as you can see, the regulation is dependent on the firing angle. When firing angle was 0, we have the pure sinusoidal wave. When firing angle was 30 degrees, we have a sinusoidal wave with a larger positive, larger negative side, but not so smooth. When we increase it to 90 degrees, we have like a quarter of it of positive, quarter of negative, and like that. So you see the voltage is regulated already. So this is AC voltage regulation. And then we have what is called harmonics. Harmonics are unwanted frequencies in load currents, which we don't want. Harmonics are unwanted. For example, I remember a time when they were designing the Burj Al Arab in Dubai. They had to make sure that they take care of harmonic currents in the building because of so much electrical load. Because if harmonic current builds too much, it can cause fire, it can cause problems. So we need to study harmonics. So as you can see, I did some Fourier analysis in the current, some harmonic analysis in the current from PSpice. And I realized that the load harmonics had an amplitude of 3.6 amperes. So this is the harmonics. These are the voltages from different firing angles. So what we have been able to show in conclusion is that the AC voltage regulation has been demonstrated and achieved with the AC voltage regulator, which is for controlling the voltage, current, and power supplied to a load from a constant AC source. So we have said that an AC voltage regulator is used to control the power, the voltage, and the current that is supplied to a load from an AC source. And we showed the electrical design of electronics of the AC voltage regulator with the input voltage, output voltage, and then we have the thyristors which are used to control, switch the voltage such that the output voltage is going to be regulated. And then we showed some mathematical equations to describe the output voltage, the RMS value, and we showed that alpha is the firing angle. And then some results to show this is our input AC voltage, this is our output if the firing angle is 0. This is also triggering or firing angle or triggering angle. Remember, it's the same thing. The angle that we use to fire. That means the firing angle is a property of the thyristor. And then this is the output voltage for different firing angle. When firing angle 30, this is the output voltage. When firing angle 90, this is the output voltage. This is the harmonics. And from the simulation, we see that the firing angle is the output voltage depend on what is the firing angle. thank you for listening. We hope to develop some more simulation models before the end of the project. Thank you again.